Hello, BJ here. Just going to review this MetalElement testing application that we wrote today. So I'm just going to take a walk through it, look through all the code, and hopefully be able to use it whenever you're trying to complete the next assignment. Okay, so what I want to look at first is the project overall. So I found this. This is uploaded in class 5, topic 3, class 5. And it's uploaded in here. It's called Metal Testing 2018-03-21 with comparable and comparator. So if you download that zip file and open it up in SAM, you'll be able to see this here code. Alright, so I enhanced it a little bit with a lot of comments since class, but still pretty much the same functionality that we reviewed today in class. Okay, so this metal testing project has a package for the business objects and a package for the metal testing. All right, so metal testing, this is the main class. You can see the little green arrow. All right, I'm going to quickly create another package for that comparator. So I'm just going to show you how to do that. Comparators in info.hccis.elementarray.comparator. Package. All right, and just for fun, I'm going to move the comparator class into that package. All right, not a big difference, but I like to keep these classes organized. So that's the purpose of these packages, just to keep the classes organized into sort of organizational units. All right, so the business object has an element class. All right, this class will represent an element, but it's not meant to create concrete objects from. And it's abstract. All right, so it can't be used to create objects, but it's only used for inheritance. Classes, in this example, metal element and non-metal element, that want to use this as a base class, they'll have to implement the abstract methods that are in this class. All right, so with abstract classes, remember abstract classes can have abstract methods, but abstract methods must be inside abstract classes or interfaces, as we'll see later. So this element class has 3 attributes in it. Okay, so notice that these are private. All right, so if I'm going to use these, my metal element class extends element. All right, so as such, it has attributes, symbol, atomic number, and atomic weight. But from the code inside metal element, I'm not going to be able to access these directly. I'm going to have to use the public getters and setters. Or in this case, just the getters. But otherwise, the alternative would be to make these protected. And then I could access them in my derived classes as well. All right, so this element class, like I said, it's abstract. It has one abstract method called describe element. All right, so metal element. All right, metal element is not abstract, and it extends element. So I know that this class has to have an implementation of describe element. All right, there's the public getters, the toString. All right, note the toString calls the describe element. All right, so that's, although I'm inside the element class, which is abstract, and I don't actually have a definition for the statements that make up the describe element method, I know that whenever I'm in a concrete object that has this element class as a base class, it's going to have an implementation for describe element. All right, you can see that over here. So metal element extends element. All right, whenever I call the toString for a metal element, it's going to use this version of it. right? And then it's going to use the described element, which is defined in the MetalElement class. I'll change it a little bit here. I'll say metal, good conductors of electricity. All right, so that's how the toString is going to work, benefiting from both the fact that the described element is implemented in the MetalElement class and that it's called from the base class's toString. Okay, so moving over to the MetalElement class. It's so these ones, it's not an abstract class and it extends element. We'll get to this comparable later. Okay, so I can create instances of MetalElement. You can see I'm doing that over in my main class here. All right, so I'm creating iron and I'm creating lead. I don't know that these numbers are correct. Actually, I'm pretty sure I just made them up, so they're not correct. But the constructor accepts a string, an int, and a double. So constructor, you'll see that the MetalElement constructor accepts those three attributes, and they're passed immediately to the super constructor, which accepts a string, an int, and a double, and sets the values of the attributes. Okay, so my described element is implemented here. All right, my MetalElement also has a couple of other overrides. It overrides the equals method from the object class. All right, so to override the equals method, the signature of the method has to be exactly the same. So it's public boolean equals and accepts an object. So what I'm going to do is, in an object of type MetalElement, if I call the equals method, I'm going to pass it another MetalElement. All right, so I'm passing in an object. And what I'm doing here is casting that object to an element. So T is an object. All right, and I know that if I'm going to be using this correctly, I'm going to be passing a MetalElement to it. All right, and I'm taking that. Well, a MetalElement is an element. So I'm casting that element using the casting operators here into an element object called that. All right, and that's what I need. I need to do that in order to call the getSymbol method for the object which is passed in. If it's defined as an object here, I can't call a getSymbol method on it. All right, so all I do once I have that casted over to an element, I just say this.getSymbol. All right, so the symbol of this MetalElement is dot equals. All right, and that's the equals method from the string class. I could put equals ignore case if I wanted to. All right, so the string symbol for this object equals the symbol in the object which is passed in to the equals method. All right, if they're equal, this method will return true. If they're not, it will return false. All right, so I've got another method overridden from the object class is the clone method. It doesn't throw the clone not supported exception. That's fine. We didn't do exceptions yet. So for now, I'm just going to do it. So what a clone is going to do is create another instance of a MetalElement, and all the attributes of that instance are going to be set equal to the attributes of this instance, and it returns it. All right, so this gives me a way, if I have an object that I'm working with in my code and I want to create an exact copy of it, I can just call the clone method of this object. Okay, so that's the basics, the way that the classes are set up in this example. Finally, we're looking at some interfaces. All right, so you see what I'm doing here? I'm creating two MetalElement objects. I am adding them to an array list of MetalElements called elements. All right, so now my elements array list has two objects inside it. I am outputting them. Okay, so here's where I get into the comparable. All All right, so collections.sort, look at this method. It accepts a list of type. All right, so the thing is, the list of objects that get passed to the sort method have to be of a type of a class which implements the comparable interface. So if I want to use this method, my MetalElements, alright, so I've got an array list of MetalElements. My MetalElement class has to implement the comparable interface. Alright, so I pass the generic type. Whenever I say implements comparable element, it knows that the compare2 method, alright, so the comparable interface has one abstract method inside it. So interfaces are going to be used to hold constants, and they're going to have abstract methods in them. The one abstract method which has to be defined if you implement the comparable interface is the compare2 method. All right, so that's what we're going to do here. All right, so it's going to pass in accept that or an element object, and so I'm going to compare this object's symbol to that object symbol. All right, so so if they're equal, the two symbols are equal, what I'm going to do is compare the atomic number. This is sort of similar to the equals method, but so what I'm doing is taking the atomic number. So this atomic number, so say this metal element was lead, and it hypothetically was 55, its atomic number, and I was comparing it to, say, iron, which is 26. So 55 minus 26 will give me a positive number. So if the symbols are equal, the tiebreaker is going to be the atomic number. So I'll return a positive number if the atomic number is bigger for this object than for the one that I'm comparing it to. All right, so otherwise, if the symbols aren't the same, then I'm going to compare this symbol, and I'm going to call a compare2 method from the string class, which is going to give me a positive number, or if this symbol is bigger than that symbol. All right, so it's going to go into the strings and compare the, it's going to compare each character in the string to the other corresponding character in the object that's passed in, the symbol of the object that's passed in. All right, so ultimately this compare2 is going to return a positive number if this is greater than that, a 0 if this is equal to that, and a negative number if this is considered smaller than that. Right? And in here we just define how we determine if something is bigger than another object, if this object is bigger than that object. Okay, so there's quite a bit of code there that we're looking at inside the main method here. All right, once I call the collections.sort, this sort method is going to use the compare2 and do some kind of sorting algorithm and put the objects in the array list in order. Okay, finally, the last piece of this analysis here is to looking at this other collections.sort. All right, so this overloaded sort method accepts an array list and it accepts a comparator. All right, so I'm creating a new comparator class and passing it to this sort method. All right, so if I want to look at what that comparator is, it's just a little class that implements the comparator interface. Metal atomic weight comparator, so that's just the name of my class. And the only thing that, the only abstract method that this class has to implement is the compare. You note the comparable, to be implement the comparable interface, you had to implement the compare2, and to implement the comparator, you have to implement the compare method. Okay, so the difference is the compare to accepts one object to compare to. The compare method accepts two. All right, and basically this here comparator is set up to compare based on atomic weight. So what I'm doing is I'm taking M1, the first object, subtracting off the atomic weight of M2. All right, that's going to give me back a number. Say, in the example here, I've got, it's going to say say which one's going in first? Whatever one I'm comparing to anyway. So 55.7 to 133.7. All right, so if I'm comparing the big one, the 133.7, to this one, it would say 133.7 minus 55.7, or whatever the numbers happen to be for the two objects that are being compared. All right, so this is just going to return a positive number if M is large, M1 is larger, a negative number if M1 is smaller, or 0 if they're equal. All right, and you notice I cast it to an int because I don't want this returns an int. All right, so if it comes back to, whoa, bit of a bug here I never thought of up till now. All right, if we cast it to an int, and it comes out to like 0.1, then that's gonna cast it down to 0. So yeah, anyway, it's a bug we'd have to deal with, but for most of our purposes, so that's just one little bug I never thought of up till now. But anyway, you're casting it, say 0.5, cast to an int is going to get back 0. So might have to handle that somehow. The important thing is that it returns a positive number, a negative number, or a 0. All right, so if I multiply by 1,000, if it's plus, the difference between them is plus 0.020, then it'll put it to a positive number. So this will handle it as long as they're within 1,000th, 0.001 or whatever. So anyway, that should handle the problem. Important thing is that it returns positive number, negative number, or 0 if they're considered equal. Okay, so that's the compare method. And back in my main class, my collections.sort, which accepts that comparator, will sort the objects according to that algorithm defined in here. Okay, so the last thing I want to do is create one more comparator. Okay, copy that and paste it. All right, so it's going to be an atomic number comparator. All right, so now based on atomic number, it's almost the same, except 2, but instead of comparing atomic weight, I'm going to compare atomic number. Right, these are ints, so I don't need to worry about them. Don't need to worry about the decimal places not being more than 1. Okay, so now I've got another comparator defined. So what I can do is, in my main class, I can also sort them based on the atomic number. Atomic weight comparator, I can pass atomic number comparator. And it doesn't like that. Import the class. Once it's imported, it knows what this comparator is, and it can do its sorting. So once this is called, you notice that the elements array list is passed into the sort method by reference. So whenever the sort method does its rearranging of the elements, whenever it's finished, the elements array list is also modified so that the elements inside the array list are now sorted. Okay, so that's a look at interfaces, abstract classes, and some processing using all these metal elements. Notice I didn't really use the non-metal element class in this example, but anyway. Okay, I'll post this in SAM. Hopefully, if you have a chance to watch it slowly, you can follow along in the code and see what's up.